And thank you for giving us the opportunity to present our BLADE2CIRC project, especially to you, Marco and Amanda, who have been in contact with us. So as you said, I'm Leyre Hernández. I work at Aitiip Technology Center that is located in Zaragoza. And I'm the coordinator of BLADE2CIRC project that is a sister project of EOLIAN. So we have a lot of things in common, but let's try to focus in those that are a bit different to feed each other. So our project title is BLADE2CIRC, forging the blades of the future with composite materials with circular, safe and sustainable design, so very similar to yours. And in our case, the project started on the 1st of April 2024 and will be working during 42 months. We are right now in month 21, so just at the half of the project. So the problem, solution, and scenario is something that we shared. So I'll be brief. So as you know, wind-based power generation is going to increase during the following years to become climate neutral. But one of the problems that we have with that is the sustainability of the materials with which we are manufacturing the blades currently. So our aim to solve this problem here is to develop new circular and greener alternatives, focusing on the origin of the materials and on their end of life of the materials that we use for the blades. So our methodology focuses on 5 different technology blocks. The first one is, as I was saying, alternative sustainable materials. And we are developing, the same as you, bio-based thermoset and dynamic resins to develop the biocomposites, which I think in this case is very similar to you, but we are also developing bio-based carbon fibers made out of lignin to form our biocomposite materials to substitute the glass fiber materials. So here you can see one of the first coupon samples that we have obtained also by vacuum infusion with our project carbon fibers and our project resins. The second technology block is related to the end of life, to the recycling routes, and we are focusing on 2 different technologies or ways. The first one is to support the disassembling of the blade, and it is the bonding on demand strategies. We are developing a reversible adhesive to help disassembling the blade. And also we are working on chemical and enzymatic routes to recycle, to dissolve the composite that we are manufacturing, to dissolve the resin at the end of life of the blade and recover again the fibers. The third technology block we are focusing is to focus on enlarge the life cycle of the blade. So we are developing a coating with self-healing properties. So we develop these microcapsules that you can see here, and we encapsulate building blocks of the resin of the coating, so that if it breaks for some environmental reason or whatever, it just self-heals the coating. The fourth technology block that we work is related to modeling, simulation, and testing. And here we are doing simulations at different levels for different purposes. So at the lowest level, we develop molecular dynamic simulations where we simulate the bonding and debonding of the dynamic resins. We also do computational design of the microcapsules, micrographic analysis to see how these capsules are going to behave once they break in the coating. We are also developing multi-scale modeling to see the behavior of the different composites of the waving of the carbon fibers. And finally, we are doing damage computational models to study the fatigue-related models of the blade, and we are doing so by finite element simulations. So we are going for the very small scale of the bonding of the resins to the fatigue models of the complete blade. And finally, we complete our technology blocks with sustainability and circularity, of course, with LCA studies and everything, but also we are doing system dynamic modeling to study the different end of life scenarios of our blades. So that would be more or less the summary of the different technologies that we are using and related to, well, who is doing that. So this is the consortium that is doing all the work here. I'll go one by one very quickly. So specific polymers from France is the partner who is developing all the polymers, as you can see, all the resins, the dynamic bonds, and everything related to the resins indeed. Centex Bell from Belgium is doing the waving of the carbon fibers. KT8 from Sweden is working on the system dynamic modeling. Aitiip Composites is, in our case, the final manufacturer of the blade. We were less ambitious, let's say, and our blade will be just 1 meter long demonstrator, and it will be done by Aitiip Composites. University of Limerick is working on the development of bio-based carbon fibers. The Spanish Research Council, jointly with Ebonzyme, who is a spin-off of them, are working on the enzymatic routes for recycling. Incotec develops all the exploitation of the project. ITA here in Zaragoza works on the coating and on the reversible adhesive. Moses, that's Aitiip's spin-off, is doing all the upscale of the resins. And finally, at Aitiip, we are focused on developing DL-Sandler's adducts to support the dynamicity of the resins, and also we are coordinators and we are the leaders of exploitation too. So I think that's everything from my side. So, well, thank you again for inviting us. And if you have any questions, we will talk afterwards.